Yes, my name is Abir Magina, and this marks our very first session into our PLTW Digital Electronics video tutorials. And the goal of these videos is to clear up any gaps in your knowledge or any misconceptions you may have, and we'll do that by going through the PLTW syllabus and making lots of small hands-on projects which should be like pretty good examples for each of the topics that you guys are gonna go through in the whole PLTW class. So our digital electronics, right? So this is just our introduction to digital electronics, and digital electronics are the foundation for all of the stuff that we use today, right? You have your cell phones, MP3 players, laptops, cameras, TVs, and the whole point of this digital electronics course is to basically expose to students, to me and you, the design process of combinational and sequential logic design, teamwork, communication methods, engineering standards, and technical documentation. So this whole course is trying to expose students to the whole world of digital electronics, and this could be a potential job path for many of you guys. So if you do enjoy this course, it's important to check this out. And digital electronics, as you can see, are going to be an essential part of all of our lives, so it's important to just understand a little bit more about them. And we'll also learn about this in class, and this is just the progression of digital design tools. So you have your transistors, gates, ICs, right, integrated chips, programmable logic devices, microcomputers, and the microcomputers are our Arduino, if any of you guys are familiar with Arduino. So what is circuit design, and how is it different from any science classes that you guys will go through? So scientists are really more trying to get answers to big questions regarding the world around us, whereas engineers use these answers to help solve a problem or complete a task. So the example that the slide gives us here is, what are the laws of nature that make it possible for that moving a wire through a magnetic field will generate an electrical current in the wire, right? And the engineer is basically trying to ask how he can use this knowledge to address a need or solve a problem. So that's what we will be going through in this class. And just to start out, let's all open up Google and go to Tinkercad. And if those of you who are familiar with Tinkercad will know that it's generally a 3D design tool, but it does also have some great circuitry features, right? We can build and design circuits in here. So to start out, click join now if you do not have a account, and let's just create a personal account, and let me sign in with my Google account, and I'll just use my existing account that I have. So it will just take me into here. I've already made an account, but you guys should just go through and fill out the process. And once you've completed it, you'll be met with this little, not really a workbench, but more of a place that's going to hold all your blueprints and your designs. So right now you're in 3D designs probably, so click on circuits, and you'll be able to create a new circuit, which will take you to our workbench, and you can see all of the basic components, which I will be explaining shortly. So you can go ahead and explore this whole thing and rename whatever you want it to be. And that marks the end of this first quick session, and there'll be many more to come, and I'll explain in the next one more about each of the individual components and how we can use them to make a couple simple projects. So thank you, and see you next time.